All right, everybody, it is time for our next talk. Our very next speaker here is Travis Altman. Now, Travis has been involved with OWASP, the Open Web Application Security Project, for a long time. He leads the Richmond, Virginia chapter, and he's going to be sharing with us some cool information on serverless, right? It is definitely hot, right? So the title is very appropriate. Travis, thank you so much for joining us. Welcome, and I'll turn it over to you.
Okay, hey, thanks, Frank. All right, so the talk here is about serverless environments. This will not be one provider over another. It's very high level. You'll notice throughout my slides, I'm very verbose in nature, but the intent there was to try and capture as much information in the slides as possible. Not trying to write a book, but also want to make sure I capture stuff. I'll state up front, the TLDR of this, right, is if you had to have one takeaway, it's probably this, that serverless is a very small attack surface. And so it's a very good idea to implement from a security standpoint, right? So it's very difficult for threat actors to take advantage of because of the nature of it. We'll dig into that further, but another thing that I didn't have bullet pointed here was to also think about it from a traditional application standpoint. So you want to implement all the things sort of Matt just talked about, right? When you're implementing some of those pipelines, what are some of those security checks you're doing as part of just any coding project? So that's the TLDR. It's small, but at the same time, you want to make sure you're also focusing on those internal interactions of serverless functions. And I'll quickly do like sort of a serverless breakdown, right? Do a 101. I do want to level set a little bit there. And then I'm going to talk about the differences in sort of your traditional application security versus, say, a serverless application security. And then I want to focus on sort of the two main approaches, right? So what might be your external attack surface in a serverless environment versus what it is for internal. And then I'm going to walk through a handful of examples that I've noticed over the years when assessing some of these environments. So real quick, maybe I'll kind of start with the fourth bullet point there, right? So serverless is the latest abstraction, right? It's this new black, so to speak. We talk about mainframes and then servers, racking those in data centers to VMs to containers, and here we are today. And some of the things that I'll note about serverless is that it is event driven, right? So it takes in some piece of data, some information, and then it performs that function, and then it ships it off, right? And so they're very ephemeral in nature, right? So they're up for a millisecond, and then they're down. So this definitely makes it harder for threat actors to take advantage of those, right? I've got the examples you probably all know and love. It's Lambda with AWS, it's Azure's functions, and it's all GCP's functions as well. So some real quick, the benefits, right? So there's no servers to manage. That's great, right? We don't have to worry about middleware. We don't have to worry about patching. Also, it scales a lot quicker, right? Let's just say, for example, you're taking in notifications from a set of users and that ramps up. Well, then it's just a multiplication problem at that point. You can spin up all of those different functions to handle that load. Also cost, if you're familiar with any of these platforms, they could get pricey fairly quickly. Serverless is a low cost solution to implement some of the same functionality you might have within a traditional application. Some of the sort of the cons in a serverless is that you're somewhat limited within, say, your full feature enterprise application. A lot of those things aren't there today, and so it's not as mature when it comes to that. But we see it growing for sure. So when we talk about traditional versus serverless, we go and look at sort of OWASP. They have a top 10 that they developed for web apps. Well, they also came out with a top 10 for serverless. News here, they're the same. When you go and look at what they've outlined, they're actually, call them interpretations, if you will, but the top 10 remains the same. So that just highlights, if you're developing in a serverless style environment, you really should be implementing the same controls and practices you have for years, although there is a slight twist. Say, for example, sensitive data exposure. Typically, we think about that with a database. Well, in a cloud environment, that's not the case, or it may not be the case. It could be, some type of queuing service. It could be some type of a bucket storage location. Same thing with cross-site scripting, and I encourage you to go and look at the serverless top 10 because they give great examples of why they might be applicable in this style. For example, for cross-site scripting, right, with a serverless application, there is no model view controller right there, right? There is no way to reflect information back to the end user. There's no way to take advantage of a DOM, so to speak, right? And so, but what can happen with that is those malicious characters can then get fed into some other cloud service and consume by that cloud service, and then you'll be able to take advantage of that way. So it's definitely worth a look, and I would encourage folks to look at that. But I'd say the takeaway from this is that turns out the approaches to application security remain the same, whether it's traditional versus serverless, although there are some things you want to keep in mind, and I'll go into those further. So I want to briefly highlight sort of the internal versus external, and we'll dig into them. But what you can think about for external attack surface is that it's somewhat traditional to a web app today, right? But with a slight twist. As Matt kind of mentioned, you'll still want to harden your systems through your traditional DevSecOps pipelines, right? So you're still going to want to run it through, say, a static code analysis. You may want to run it through some type of dynamic analysis, right? You want to say, hey, what dependencies am I pulling in? And are there any vulnerabilities associated with that? You know, think of like your traditional JavaScript and whatnot. Also, what kinds of SCA do you have? Your software composition checks, right? Are you pulling in some open source libraries? Are you pulling in any vulnerabilities associated with those? All right, so those are still things you'll want to consider, whether it's traditional web app or it's serverless. Another thing to think about from the external attack surface is API gateways. I don't really want to get too deep into API gateways. There's a lot of information out there. What I suggest is that you look at some of the common best practices to implement API gateways, right? So whether that's authentication, load balancing, there's a lot of good information out there, but an API gateway is a key component of any externally facing serverless function. So I encourage you to implement those and implement those properly. And I would say the backend is crucial, which is going to lead into the internal, right? So what are your functions doing, right? As you're engineering these systems, right? What is the intent of those functions? What are they going to be touching other services, right? Typically, your serverless systems are going to be like doing transactional type data, right? It's sending out an email, sending out a notification, maybe resizing an image, right? These things are very, micro-focused, but then those tend to get picked up by other services. So you want to be mindful of that. When we talk about internal, right, you can almost think about this as an assumed compromise, right? Or post-compromise. And the internal attack surface is a much harder problem to solve. We have a lot of maturity on the application space, which we can pull into serverless, but the internal is where I want to put some energy into. And once again, you want to leverage best practices to lock a lot of services down, but I'll get into some of those examples as well. So right quick for external attack techniques, right? So serverless does pose a challenge, right? Your malicious threat actors, they can't operate the same way they do today, right? They can't really do, say, a SQL injection attack because there is no database. A lot of what attackers will do will be, OS injection commands, right, or directory traversal commands. Well, these types of traditional attacks are not applicable in a serverless environment, right? So those are just some of the challenges that I'll get into, but there are plenty of other ones, right? So threat actors have to think of new ways to exploit these systems, right? They're still going to focus on your traditional categories of attacks. So you think about your access control, your session management, your input validation. Those will still be there. But the TTPs, right, the tactics of which threat actors are leveraging, those will definitely differ from, say, your traditional attack. So instead of saying try attacking a SQL database, they're going to turn all their energy into what are those serverless functions interacting with. And just the nature of interacting with those functions, they can then say like, hey, I think these systems are interacting with maybe a queuing service, or maybe they're interacting with an EC2. So they can probably try and discern what that is doing and then focus their attacks based upon those different services. So on the right-hand side, this is a quick screenshot and it does not get into the depth of it. But this is just for AWS Lambda, right? So serverless functions for Lambda can only interact with a handful of things within the cloud environment. Now I say handful, there's a bevy of things, so maybe that description was wrong. But just think about it. Serverless functions can interact with, EC2. They can interact with S3s. They can interact with Alexa. You name it. There's plenty of services they can interact with. And what threat actors are going to do is to figure out, hey, what might the functions be interacting with, and how can I take advantage of those? So from the internal side, once again, I'll kind of read. This is a very hard thing to manage because you're essentially thinking about, I have an internal network or intranet, just like in a traditional organization, right? That attack surface is much harder to clean up, right? So you've got all these other services within there. And sort of my first bullet point there is every cloud service is a threat to another cloud service. So when you have that mentality, that hopefully will put you say, all right, I'm not going to trust anything within this environment, right? I'm going to lock it down as much as I can, because that is definitely the case with that. If an attacker lands on one thing, they're going to get a foothold, and then just like in any other type of environment, they're going to start enumerating things, right? So in a traditional environment, you're going to try and say, hey, where are my file shares? Where is the Active Directory? Are there, what are my endpoints? What are my servers? What's my middleware? This is the same thing a threat actor is going to do in a cloud environment, except it's going to be tailored towards those types of services. So really, a serverless function is an entry point into that environment, right? So once a threat actor gains that foothold, they're going to start to poke and pry. They're going to be looking for what might be weak in this environment. So maybe they've landed on a queuing or storage service. So then there are native commands, native things that they can do within those services that they can then try and discern what other information systems might have access to, what type of permissions they might have, right? So, and once again, these serverless functions, if you almost look at any example, any implementation of serverless, these things are not operating in a vacuum, right? They don't just sit there and modify files for no reason. They modify files or they make changes to systems, right? And so those are things that you'll want to really take care in looking at how you're implementing that. What are engineers doing to interact with those systems? You'll see this all the time, right? Permissions, but it's true. Whether that's in your Active Directory or that's in IAM, those things are still hard to do, and you see misconfigurations with them all the time. So you definitely want to make sure you pay close attention to that. So that's a common theme you'll see throughout most of these talks, right? So let's walk through a couple of scenarios. And I say these are scenarios, these are things that I have seen in the wild. So you want to call them scenarios or real life examples, or even if you want to do tabletop style exercises with I suggest you walk through some of these in your environment and figure out, would this be applicable to our environment as well? So here's the scenario. You've got an external facing AWS serverless application. Its function here is to process orders and then kick off an email confirmation. So the attacker notices this, they get that email confirmation back, okay? Well, what are they gonna do? They're gonna start interrogating stuff, right? So they're looking at the URL, which then drops the receipt for that application, okay? Now, if you've implemented things correctly, this is kind of where in this scenario, the developers went wrong. They tried to implement a nomenclature to hide where those locations of those receipts are, right? And so in this specific example, the attacker was able to sort of decode, that UUID, if you will. It's sort of a weak implementation of that. And then they were able to sort of brute force those confirmations. And from there, then they were able to access other users' receipts. And then they started poking around and seeing what other access they had. And then they found a temporary file locations to other serverless functions. And from there, they were able to decode the privileges, the hard-coded credentials of which those serverless functions were leveraging to connect to other systems. So sort of the takeaway here is that your traditional application security concerns are going to exist, whether it's serverless or a traditional web app, right? And in this case, they did a poor job of implementing, they did it sort of that rolled your own, right, token-based authentication. So in here, they also implemented hardcode credentials into other systems, which is all somewhat a 101 no-no. So you always want to make sure you validate and authorize the access to these backend systems, right? So who's making the request, what type of session do they have established, and do they have the proper access? Now I want to focus on the internal side. I'm going to give a couple examples around this I've seen. So in this scenario, the threat actors taking advantage of a serverless app, which lands them with limited IAM permissions within AWS. Okay, so 101, as soon as they have that type of access, they're going to start to enumerate that access, right? What permissions do they have, right? So as they start looking at, they say, hey, I have the permission to describe other EC2 instances with the current role. So then they start saying, all right, now that I know that, what other groups are connected to the EC2 instance, right? So they can describe an EC2 instance, they can then see the roles that are associated with those EC2 instances. And then they stumble across a profile that is attached to the EC2. And this is sort of the scenario which I've seen in the past, and attackers typically try and leverage, is that they can see where permissions are attached to any service, but in this case, we're talking about EC2. So through that enumeration, they find that the current role is allowed to add and remove instance profiles. So once again, they just keep going on a chain. What else can I have access to? So then they try and create an EC2 instance with those compromised permissions, which proves successful in this case. So then after creating the EC2 instance, they then try and attach those profiles to the EC2. And that's kind of where the real juggernaut of this attack comes in, is that they have other profiles that are attachable. What permissions do those profiles have? And so then they can spin up a service, attach those profiles to it. And in this case, that particular profile had admin access, which allowed the threat actor full control of the EC2 instance. And so from there, once again, they're going to pilfer some more, but that was where they landed right there. So the takeaway here is you want to be wary of profiles that are attached to certain cloud services. So that is a common threat vector we've seen in the past. You want to make sure you eliminate those. You can use various commercial tools as well, and I highly recommend that. But there are some open source tools out there, such as PMapper, which will try and help identify some weak permissions. And I've seen where other talks have also recommended, hey, here's a way you can check those permissions as well. So this is just one example of that. And this is the last scenario I'll go through. So this scenario is kind of really talking about previous IAM policies. So once again, this is another, I don't want to say a classic, but it's definitely one of the threat scenarios that I have seen and people check for. But once again, this is sort of a post-compromise, right? And so that lands the attacker with some limited access keys. And some people scoff at this, like, oh, well, you started with access keys. You'll be surprised how often that happens. It is not uncommon to determine access keys one way or the other, right? You named the example, but you've landed somewhere, and just like in the previous example, there were these Lambda functions which had hard-coded credentials in those. So that's a classic case. But either way, in this case, they've got those keys, but they are very limited in nature. So good job on the engineers and the developers for limiting this role. But once again, they're going to want to see, hey, what other permissions do I have? And so they perform a check to see what are attached to that role. So that's a common enumeration technique to say, I have this role, what's attached to it, okay? So the attacker notes that there are numerous policies attached to the role. So it's not uncommon to have older policies that may or may not be permissible, right? So if you think about it, you're developing these systems. So now you have this policy. Okay, well, that policy, we're gonna sunset that policy, and we're gonna create a new policy. We're gonna make modifications. So it's almost like a V1, V2, V3. So these policies we've seen where they'll stick around, and so they'll be policies you could go back to, but for whatever reason, they keep those as a reference, or for whatever reason, those engineers might have for that. So then you can, in this particular scenario, with the limited access they have, they could actually enumerate all the policy versions associated with that role. So they may not have been able to see all the details, but at least, hey, we have different versions of that policy. So you can go in and look at the permissions on those policies. And so the threat actor says, hey, I see where one of them has maybe some excessive permissions, okay, that allows them to roll back. And so that's another scenario here where we'll often see is, can I take that policy and then can I roll it back? A lot of times that permission is not there to do that, but as an attacker, that's something that we've seen them try before. They're always going to try and say, hey, if I see multiple policies, can I roll back? And then if I roll back, what do those policies give me? What permissions do I have if I roll back to those? So in this scenario, which is a real life example, the attacker was able to do that and gain more permissions than they had when they first started. So another takeaway here is that you definitely want to manage your versions of policies. In my examples here are very specific. You know, we talk about IAM and just permissions in general, and I've kind of highlighted that. But here I've shown a handful of examples where a couple of things where you want to, if you see attached policies, what are the permissions around that? Same thing for policies that are older policies that you allow for rollback. You definitely want to manage those previous policies and make sure you have certain roles attached to those policies. And then obviously you can use commercial tools, open source tools to try and see where you might have some of those policies that are in violations of permissions. So there are tools like AWS's IAM policy simulator, which allow you to do that. And Netflix has another tool called RepoKit, which helps you automatically identify some of those issues as well. And I think that's all I have. I'll throw it back over to you, Frank.